to be here in front of you to present a bit my path. So I will talk about science, of course, but I will also be, in a way, tell you a story, which is a bit my path in research, since the very beginning to the end. So I wouldn't say that my path was clear, and I wouldn't say that it was very direct, that I knew what I wanted to do, okay? It is not the case, but at the end, if I have to make the balance, at the end, I'm quite happy of what I achieved till now. So I start from the very beginning, okay? So from the high school. Well, I was in Italy. You can choose kind of options when you start the high school, and I picked a scientific and linguistic option. And then in the bachelor, I did art, theater, music, and cinema. Okay, so I know it's quite far from what I'm doing now, but I'm still very happy of what I did, okay, even now, because from the, let's say, building of my own person, also from the cultural point of view, it was great, okay. So I had the chance of having parents who didn't tell me, now you need to do that because then you will find a good work, and if you do that other option, then you will be just unemployed for the rest of your life. So I was free to choose, and that was great. So then I did at the end of my bachelor in Italy, I was doing a kind of a thesis, and I was working on a virtual reality. Applied to medicine in particular, so we were in a way designing the virtual reality space, okay, and I liked it so much that I said maybe I can go to do a master in computer science, okay. And when I went in front of the commission to hire me as a computer scientist, I mean to start a master in computer science, which is a two-year degree in Italy. Well, I mean, people were looking at me like that, okay, saying, oh, well, this girl is maybe nice, but okay, she doesn't know what she's talking about. So people were saying, but really, you know, you will have to do exams on maths, on physics. Are you really, really sure? Because you did cinema before, so maybe think it better. But I had the chance to find a number of scholars to whom I'm really grateful, even now, that trusted me and said, okay, you can do that, okay, try, okay, at least give it a try. And I did my master, so I would say I succeeded. It was a master in computer science, and more precisely in artificial intelligence. I was mainly working on multi-agent systems, which at the time was more or less what is now called agentic AI. So yes, it was already there, this word. And I started working on what is the core topic of my research till now, which is argumentation theory. So that was a bit the starting. So I did this master. I liked it a lot, and I liked it so much that I decided to do a PhD in computer science, and I did a joint PhD in Torino and at the University of Luxembourg. Okay, so I had two supervisors. That was also something that I learned to do in a way, because having two supervisors means also that you need to juggle between the two. Okay. And I had one in Torino and one in Luxembourg, so they were not even in the same place. That was a kind of a challenge as well. but they were great. And I did a PhD in abstract argumentation theory. So it was more what we would call now symbolic AI. That is the path, let's say, till the PhD. Then I decided to move because also it is a kind of even with a joint PhD between Italy and Luxembourg, there is anyway a need also to see something else, and that was a bit let's say tough at the beginning, but definitely it was something that brought me a lot. So I moved for a postdoc here in Sophia Antipolis, and I was hired by the Inria team Wimix by Fabien Gandon. And I was working on an ANR project called DataLift. Okay, so that's not a secret. I'm still here, so it means I liked the environment. But that was the way I arrived here. So let's talk a little bit about my research, and what I want to show is not only let's say tell you my personal and academic story, but also to show you how research evolves during time with the years. So the point is, you need to have there is some change. There are some changes also that happens when you do research on a topic, because there is an environment around you, and I think that we have a big suspect in all that, which is generative AI, which sometimes comes and changes a bit the game without you expect it. So my main research topic is what I call argument mining. So what is argument mining? Basically, argument mining in few words is how to understand how people propose arguments. Arguments are what we exchange every day to take decisions, to put forward our own opinions. I think that in particular politics is a good scenario, okay? So when you say I did that because of the reason and so on, so all these are arguments. And there are many kind of argumentation that are proposed in different domains. So there is argumentation in medicine when you want to argue about a certain disease and a certain treatment. There are arguments in politics, as I said. There are arguments on social networks of different kinds, good arguments and less good arguments. And in law, there are arguments when you want to say, so this person has to be condemned or not. Okay, so being able to analyze automatically these arguments is the main topic of my research. So basically, the idea is that we want to start with something like that, so that some text, okay, which could talk about whatever topic, and then we want to automatically extract the structure of this text under the form of an argumentation. Okay, so basically what we extract here is that we identify one claim, what we call the one claim, which is the one in the blue square. Then we add three premises which support or attack the claim or the other premises. And basically what you have then is an argumentation graph, where you have arguments which attacks other arguments. You could even have, and I think politics is a good example in all that, arguments which attacks themselves, okay, at a certain point. So you can use these kind of extraction to identify inconsistencies, for instance. So the argument mining pipeline is kind of standard. It was standard, at least when I started working on that in 2012. So the point was, we start with an argumentation theory, how you want to structure the argumentation. Then of course you annotate some data, because basically what you use are supervised machine learning methods. And then you test, and if you are lucky, then results are good. Otherwise, you need to revise either the model or the annotation you pursued. So basically, I would decline my research along 3 steps. The first one is mining the arguments from text. So how we extract the structure, these argumentation graphs automatically from the text. Secondly, how to assess the quality of the arguments we mine. And then how to generate new arguments. So that comes more to what is generative AI. So we started working on that in medicine, for instance. So in medicine, first of all, it was quite hard to find some data. We worked on the PubMed repository. So we analyzed the abstracts of PubMed articles to automatically extract the structure of the arguments. So why is it useful? But because if you have, for instance, a certain disease and a number of treatments that could be used to in a way address this disease, then you have results which could be aligned, meaning you start from the same clinical evidence and then you achieve the same conclusion with the study. Or you could have that similar studies comes to different results. And this is important to know for clinical doctors, okay? So in order to have what we call the evidence-based medicine, so to understand how this is related to each other. So given that this was the beginning of this area, which is now well established in natural language processing, in NLP, we had to build data sets, okay? So it takes a lot of time to build these data sets. Because it was manually built, meaning that it was a manual annotation of the textual data. Why I'm saying that? Because it took more or less kind of 6 months to the PhD student who was doing this thesis to annotate and to finalize the data. And of course, he was a computer scientist, so he was not, super happy of doing this manual part, okay? But then he also, saw that what you can achieve when you build a nice resource, then is very good. So here, what I want to say is that sometimes it's not just, I take some data, I don't care if the data is good or bad, then I run some models, anyway, now everything is more or less implemented, and I take the results and I throw them in a paper, okay? Sometimes the process is longer, often is longer, but it is for a good reason, okay? So basically what you achieve then is much more important and of quality. So here we achieved some, I would say, good results. This was the pipeline, which might seem a bit old-fashioned now. And the idea was we start with the randomized clinical trials, then we have a sequence tagging module where we identify the different argument components, so the premises and the claims, which are text snippets. And then we move to the relation classification, so we are able to extract which kind of relations hold between the identified components. We build a graph, and on the graph, you can reason on the graph, okay? So you can apply then symbolic AI algorithms to reason on top of that. And then we also analyze the outcome. From that's also something that I want to say. From that, we released a demo, okay? So sometimes demo papers are a bit underestimated, okay, because you say, yeah, but it's just a tool, okay. But sometimes giving something that, in a way, people, and in people I include researchers, colleagues, but also the general public, okay, other users can use, is a nice way to make your research visible, okay? And in realizing something like that, it is also a nice way to, in a way, popularize your research. And this is something important. For instance, here we have a demo which is called ACTA Antidote, which is available online, and you can play with that. You can select the articles on PubMed, analyze them automatically, and get the argumentation graphs, the PICO information, which is information which clinical doctors use. And so when you discuss with doctors, then you can really have a matter of explaining easily what you are doing, no matter of what is the complex model transformer you are using behind, okay? So that I think it's an important point, and it is important in particular when your research is cross-disciplinary, okay? So if you're not just working with computer scientists and mathematicians, then it is good to have some kind of applications. Then we were so happy about the results on medicine that we said, so it seems really feasible, let's move to a more challenging scenario, let's move to political debates. Well, there it was a bit more complex, so in a way we had to be back to reality, because the abstracts of PubMed are really, in a way, first of all, they are short text, and second, they are more or less structured always in the same way, okay? Because these are articles in medicine, so before you have all the premises, then you have some notions on the different groups that are analyzed, and then you have at the end it comes the conclusion of the study. So more or less this is the structure, and it's always the same. But when you come to political debates, and I think that these days I'm not learning you something unexpected. Well, you don't have always, I would say that maybe you rarely have a well-grounded arguments, so that you have given that premise 1, premise 2, premise 3, then I claim that claim, okay? It's a lot of claims, announcements, and so on and so forth. So first of all, there is no structure, and there are a lot of contradictions as well. Anyway, that was our challenge. We started working on the data. So on which data? We decided to work on the presidential debate of the US, because first of all, because this data is available, and this data is available from official transcripts. And that's important because we don't want to inject any kind of disinformation, okay, we picked this debate, but this debate never happened, okay? So that was the point. We started working on that, and we picked all the debates, so from 1960 to 2020. That was kind of interesting also to see the evolution in the way the debates are addressed. That's also another important point, because of course the kind of arguments, not only the topics, but the kind of arguments that are discussed in the first debate, so Nixon-Kennedy, are not really the same that in the last one, just to give an example. So here there is some examples. The data is difficult. This kind of data is very difficult because sometimes it's imprecise, sometimes it contains a lot of implicit arguments. Okay, not everything is explicit. It grounds a lot also on the notions that you could have from politics. So here, for instance, we have the claim is the one in bold, we've been effective, and then we explain why we've been effective. So we busted the AQ-CAN network and so on and so forth, and we have different premises which are in support of the claim we have been effective. And then this is what you get for 3 turns, so you can see that these debates are really, really huge, okay? Which means that, what is the difficulty? The difficulty here is that, well, you want to retrieve relations between argument components, which are very far in the debate, okay? These are 3 terms, so this is just the argument graph that you extract, you predict, starting from that, okay? So it was huge. What was huge here as well, as you might expect, was to make the gold standard, okay? Because that was, again, manually annotated, okay? And it was complex because, first of all, you need to find annotators with the right, let's say, characteristics, meaning that they know a little bit about politics and so on, but they are not biased. So, I mean, it's not that straightforward. And then you need to address all the annotation phase and the agreement then. So what we did is that we did a pipeline of this kind, which achieved quite good results at the end of the pipeline to detect the argument components and the relations. So you see already language models. So you see already bidirectional, let's say, embeddings. So here what you have is Bert and Roberta. Okay, it was the time of the, let's say, Bertology moment, and there was not yet GPT-like models. So what we did from that, again, another demo, okay, which is called Disputul, which is available online as well. And on that we had two parts. First of all, you can analyze your own debate on the fly, if you are interested, and secondly, you have all what is a data exploration step, which is quite interesting, meaning that given that we had a gold standard, which was manually annotated and validated, you could have a data exploration looking, for instance, for the kind of topics that are mostly discussed by the two candidates. So here, for instance, you have Kennedy and Nixon, and you can see the percentage of arguments proposed on one topic or on the other topic by the different candidates. And then time flies, so I got, after my postdoc, I got a starting research position at Inria, which is a kind of a fixed term research position of 3 years. So that's what I did from 2012 and 2015. And then I get a tenured research position at CNRS, Chargé de Recherche, from October 2015. And then, of course, many things changes, so not only on the academic life, but also on the personal life. So some new constraints, some small constraints comes, which change a bit the way you can do your own research, but it doesn't, let's say, block you. And then what comes also are new responsibilities, okay? And sometimes these responsibilities are seen as something which, in a way, slower your research, okay? But actually, you should really see them as in a way, a way to learn more, to push you behind, okay? So really to, in a way, to look to the next steps, and also to interact with researchers from other fields, which is very important, and it's something that can just enrich your own research. So I had the habilitation to direct research, the HDR, in 2018. I became the deputy scientific director of the 3A then in 2021. I started having my own PhD students, which is also a big responsibility, because it is, first of all, it is a human responsibility and also an academic responsibility. So on the one side, you need to be there for them. On the other side, you need to build their network, help them at least to do so. And on the other side, which is something which is sometimes less visible to the students, is that you work on research proposal applications or other, let's say, tasks like that, which takes you a lot of time. And sometimes you are so dedicating a bit less of time to the students, but this is for them as well, in order to them get money to travel, to meet other researchers from the projects, if the project is accepted, and then it's also something that you can really give back, and it's important. Then you have, I become Directrice de Recherche, so senior researcher at CNRS, and I have been nominated to the National Pilot Committee on Digital Ethics, which was a committee which started at a certain point with different, with persons from different places, mostly in Paris, but from other places in France as well, and with different competencies. And this is important. So there were lawyers, there were jurists, there were computer scientists, mathematicians, philosophers, and so on and so forth. And that was really nourishing. Okay, so it was great to work with these people to increase, and then some new project comes to be accepted. Well, then we move to the quality part. At a certain point we said, okay, but we analyze arguments and so on, but not all arguments has the same quality. Not all of them are good, okay? Arguments, you can propose many, but then some are good, some are less good. I think we have many examples. Some of them are there. Well, we started working on how to identify fallacious arguments in text. So what are fallacious arguments? Fallacious arguments are arguments which are, in a way, let's say, they're not fake news, okay? But they are explicited in a way to mislead the audience, okay? It's kind of, it could be casted to propaganda in some cases, and in other cases they, for instance, they use a lot of empathy, emotions and so on in such a way that the audience adhere to the point of view which is proposed. And sometimes, let's say, some aspects are just skipped. I mean, you don't, in a way, say that it wasn't true, but you just, in a way, avoid to mention certain points. So here you have different examples, appeal to emotion in the Bush-Gore debate. So you have gun laws are important and so on and so forth. And then you have a very emphatic sentence, but so is loving children and character education classes and faith-based programs. Some desperate child needs to have somebody put their arm around them and say, we love you. Okay, so this is very emphatic, okay, but actually this is not the point of the discussion, okay, the point of the discussion are gun laws. Then you have Trump-Clinton, so you have, for instance, here it is another appeal to emotion. Then you have, if you go with what Hillary is saying, in the next month you can take the baby and rip the baby out of the womb of the mother just prior to the birth of the baby. So talking about, in general, talking about kids, about babies, about poor people, it works every time. So that's a bit the challenge. Then you have ad hominem attacks, so attacks which targets the opponent. And this is also something which is fallacious, because basically you should attack the idea, if you want, the proposals of the other political party, but not the person itself. So here I think you see so many examples of that. I don't have to go into the details. You have loaded language, meaning that you it's not just insults, but kind of, okay, so really using a language which is not appropriate. Then you have appeal to authority, which is used a lot by politicians, not only, of course, but saying, okay, if I say so, or if this person says so, given that he is an expert on that, you should trust him. Okay, so here this is what, if we suffer defeat in Iraq, which General Petraeus predicts we will. This is really, he said that, he's an expert on war, so trust him. And then you have slippery slope, which is a bit more subtle as a kind of a fallacy to identify. So the fact that you basically you say that from a small event, in a way, this raise a huge impactful event. Okay, so here, for instance, Nixon said, what do the Chinese communists want? They don't want just Quemoy and Matsu. They don't want just Formosa. They want the world. Okay, so that's the big message. And then you have false cause, which is even more difficult to be detected, meaning that you go into the causal reasoning. And that's difficult because causal reasoning from the, let's say, from either the data point of view or from the formal point of view, it's kind of more easily doable when you have some kind of the old data, but here there is a lot of implicitness in the causal relation, which makes the task a bit more complex. So, and here you have, for instance, a false cause example from Nixon. I would remind Senator Kennedy of the past 50 years. I would ask him to name one Republican president who led this nation into war. There were 3 Democratic presidents who led us into war. I don't mean by that one party is a war party and the other party is a peace party, but, okay? So it means basically we always go on war when there are Democrats, so infer the consequences by your own. So what we did again, we built a data set, so that was a huge work as well, annotation, agreement, and so on and so forth. Took a lot of time. Here there are some statistics, just one point. It's interesting to see that there is a hype in 2016. I don't go more into the details of what the candidates was in 2016. But more fallacies there than in previous years. So this was the architectures. I will not go too much into the details. So basically, it was a classification tasks, and here this allows us to identify the main points. So, and then it comes the generation part. So we started working on generation in argumentation before the hype of generative AI. So we were generating explanations for the medical domain, and we were doing that on clinical data, so explaining why a certain diagnosis is a good diagnosis and why other diagnoses cannot be the good ones. Why? This was to do for training, so for training residents in medicine to, in a way, better motivate why they go for one solution or the other. And it was done based on patterns, language patterns. Let's say we were taking a pattern which was fixed, and then we fill it in with the right name of the disease, the right symptoms we were taking into account. And then it comes to generative AI. It was not really, let's say, expected as it was. It changed everything, okay? And in our domain in particular, that changed everything, because then generation becomes something which was much more effective on the syntactic point of view, okay? I still think, and it's not just my thought, that actually LLMs are great for what is generating the text. Okay, but still we still have a lot of problems on what is the content, okay, the faithfulness of the content, the quality of the content, and so on. Because there are all these issues which arise every time. So the relationship to truth is important, because when you analyze some arguments, when you generate some arguments, ideally you want to generate some arguments which are of good quality, because if you detect quality on the arguments of the humans, but then you are let's say you accept all quality from the arguments you generate, that's not so good. And then there are other more ethical issues concerned to LLMs about human qualities manipulations and all the environmental challenges that arise from that. So we had 2 works from a PhD student who is in the room. So we actually tried to assess first if guardrails are effective. So LLMs are in a way equipped with guardrails such that they cannot generate some kind of content which is abusive, okay? So it's not just swear words, okay, or insults, but also all what is, that's why I was talking about manipulation, because you can go even farther to hate speech, and you can go even farther, like pushing people to suicide and so on and so forth. There are some cases which are in discussing nowadays in the actuality. So what we did is that we were trying to we were understanding first of all, given a structure in the arguments, how in a way the counter speech, the counter narrative, which is automatically generated by LLM, is in a way strong or convincing with respect to a counter speech which is generated with or without guardrails. Okay, so here you see the 2 an example of two counter speeches. So one is with guardrails, the other one is without guardrails. So for what you can say is that with guardrails, it is very general, okay, the counter speech you generate. So it's something like you shouldn't be racist because it's not good, okay, and so on, okay. But that's not very effective. Okay? If you want to people change their mind on that, there will be no way. So the one without guardrails, so without the imposition of these constraints this was on Mistral, that is more effective. So this is also something that we might take into account, because of course guardrails are a lot advertised by LLM producers, but then that's a point. So I will go, and there are more to, and then another challenge is where actually when you generate a counter speech, for instance, you want to be sure that what is done is in a way a good point, meaning that you want to be effective and to put in a way reliable information in the counter speech you generate. And that's what is currently done in our team. So how to generate counter speech based on RAG. So this is something which is very popular nowadays. Nowadays we have RAG and agentic AI. That are two hype in this moment. So how to build a knowledge base on that, and how to generate a counter speech on that. And that is, of course, what we proved is that it's much more effective than just a counter speech, a generic counter speech for that. So this is always about. So there are a lot of issues about LLM that could be discussed. So how you want to integrate social values, filters. That's very hard. All the red teaming and relational learning with human feedback approaches could produce some good results, but that's far from being straightforward. And then just to conclude, I should be on time. There are other, just to conclude the path, I'm really happy to have been able to set up an Inria team, which is a joint team, as Chadi said, with CNRS and Université Côte d'Azur, on this topic. You can trust me. When I started the PhD, working on argumentation was not the most popular topic you could pick, okay? And being able then, many years after, to have, in a way, my own team on this topic is something which makes me very happy. And then I have been also the honor to have been invited to join the CNUM, the Conseil de l'IA du numérique, which is a national committee in particular on AI, but also on, in general, computer science applications. And that is very important because we work really in order to make a bridge, ideally, under in a way, the institutions, okay, at the governmental level, and citizens. So try to make a bridge in terms of knowledge. And I have been also invited to join the National Committee on Digital Ethics in September. And that also I'm really happy about that because there are many ethical issues which arise from our implementations which need to be taken into account. And then what it's something which makes me really happy is that even if I participate to these committees, which of course it's very time consuming, okay, and of course you are not remunerated for, okay, just to be clear on that, okay, it's just really you do that for the pleasure, you do that for science, okay, and even with that I comes to achieve to have an ERC, okay. So that I think it's a nice message. It's not just because I'm kind of a superwoman. That's not the point. I just worked a lot for that. That's a huge work, writing an ERC and so on and so forth. But it means that all these different activities actually build you as a researcher, okay? And all that helps you then in being better in your own field. Okay, and that I think is my take-home message before concluding. And then, of course, this is not only my own work. This is the work of a lot of people, in particular my wonderful PhD students. So I've been very lucky during the years since the beginning to now to have been surrounded by great PhD students, postdocs, and colleagues, of course. So that's all on my side. Thanks a lot, and if you have questions, I'm happy to answer.